All right, I want to summarize this idea of solving triangles that we've been working with for the last few sections. We've dealt with the law of sines, the law of cosines, we've dealt with the angle sum formula where the angles of a triangle add up to 180. And now I just want to show you just a general approach to solving a triangle based upon what information is given in the problem. And so the first scenario is where you're given two angles and one side, okay? So the first thing, two angles and one side are given, okay? Two angles and one side. So let me draw out a triangle real quick here. Call it ABC. And opposite sides are little a, little b, little c. Now I'm assuming there's no right angle here, but there could be. Right angle is a possibility. So if you're given two angles and one side, it doesn't actually matter which combination they're in. You could have two angles and the side between them, or two angles and one of the sides adjacent, that not between them, okay? It's possible. So you could have an angle, side angle situation, right? Angle, side angle, or you could have an angle, angle, side situation. All right, either of those. Now in either case, if you have two angles, then you can immediately solve for the third, no matter what, using the angle sum formula, right? So you can find the third angle with A plus B plus C equals 180. Right? So you can use that formula to find the third angle right away. And then after you've done that, you still have two more sides to find. Well, those two sides can be found using the law of sines, because as soon as you have all three angles, so you have all three angles and one of the sides, you'll have enough information to fill in one of the ratios in the law of sines. Okay, at least one of the ratios. I guess one of the ratios for sure. So find the other two sides with law of sines. Okay? Then you're done. Right? You can find those two sides. You'll have the three angles. You'll have the original side, so that'll be all six pieces of information. Okay? So that's the first type of problem, and it works regardless of which situation you have. As long as you have two angles, you can find the third very quickly by subtracting from 180, and then you can use the law of sines to find the two missing sides. Okay? And that'll work every time. Okay, so that's kind of your most basic situation. Now we have the situation where you have two sides given rather than two angles. Okay, and now this is split up. Now, here we had ASA and AAS. Well, let's switch those letters around essentially to get two sides instead of two angles. So you could have two sides and one angle are given. And so you could have SAS or SSA. Right? Those are your two possible combinations. You could have two sides with the included angle, or you could have two sides with another angle. Sometimes we call it the angle side, although we don't like to use that abbreviation very much. And so that's the angle side is what we call the ambiguous case, where you could have a variety of possible triangles depending upon how those values were given. Right? So this one is the ambiguous case. Okay, I'll talk about that in a moment. And the other one here, the side angle side, so that would be two sides in the included angle. that's the case where we use the law of cosines. Okay, so we have now these two different scenarios with two sides given. Well, the ambiguous case you've seen all really depends upon the size of the information given, the sides and the angle. And so remember, I used the example, if you were given side A, side C, and angle A, we'll use that as our side-side angle combination just for reference here. Then the first thing you really need to do is compare A to both the C and the height. Remember, you could drop in a perpendicular line segment from the vertex down to the opposite side there. And you have to compare, we'll call that H. You have to compare A to H and C to determine how many possible triangles there are, okay? So that's the first thing, is compare A to H and C to determine how many possible triangles exist. Okay? So we know that there could be 0, 1, or 2 depending upon how long side A is, right? If side A is too short, if it's shorter than that height, then there are no possible triangles. If side A is longer than the height but shorter than C, you end up with two possible triangles, one obtuse and one acute. Okay? And if A is longer than side C, then there's only one possible triangle, be kind of like the one drawn here, because if you tried to swing that to the other side, you would go outside the triangle. Okay, so there's a couple options there. And of course, if A is obtuse to begin with, then you have fewer options, but similar options based upon how A compares to the height and C. So just remember those, that comparison. Then you would want to, so if you're given little a, little c, and big A, the A's are opposite each other, which means you can fill in one of the fractions in the law of sines. Little c is then opposite big C. So big C is what you would want to find first, right? So find big C. Now, of course, if the letters here are different, then you just have to adjust things to make sure that you're finding the angle opposite this middle side here. So find C using law of sines. Okay? Once you've found that one, you can then use the angle sum formula to find your third angle, and then the law of sines again, right? So use A plus B plus C equals 180, and law of sines to finish. All right? That's really the hardest case, in my opinion, is the one where you have the side-side angle situation, because there's so many possible outcomes. Now, we look at the law of cosines, where you have two sides in the included angle. Well, that one's a little bit easier. The problem is you can't use the law of sines right away because you don't have any one ratio filled in. So, what we tend to do, if you have the side angle side, is you use the angle, the version of the law of cosines that corresponds to the angle given, and you use that to find the opposite side. Okay, so use law of cosines to find the side opposite angle, oops, given. Okay, so whatever the angle is that's given, you want to use the law of cosines to find the opposite side. Then from there, you'll have an angle and the opposite side, so you can use the law of sines to find the other two angles. Okay. However, you always want to go with the smallest angle first, because it's a guarantee that the smallest angle will be an acute angle. And so if you find the larger of the two angles first, there's potential it could be an obtuse angle or an acute angle, and so there's some ambiguity into whether or not you're going to get a first or second quadrant angle out. So it's best to use the smallest angle first because there's a guarantee it's going to be acute. You can't have two obtuse angles in the same triangle. So use law of sines to find smallest remaining angle. Okay, I'm abbreviating here just a little bit to save some space because we're getting tight. And then of course use the law of sine, or actually once you have that angle, you'll have an angle and then another angle. You can use the angle sum formula to finish that off. So use a plus b plus c equals 180, the rest to find the last angle. So I'm running out of room there. I'll erase some of this for the next part. Okay? Alright, so that gives you a pretty good summary of these four situations, right? The four situations are, you've got two angles given or two sides given, and then the order of which they occur is important, right? So that gives you four possible different scenarios here. The other really important one is where you have three sides given. Okay? So let me erase a bit here. Okay, so option 3 is you have three sides and no angles given. All right, we call that the SSS situation. Okay, so with SSS, again, you can't possibly use the law of sines because with three sides, you don't have any side and its opposite angle known, so you can't fill in a full ratio in the law of sines. You also can't use the angle sum formula because you don't know any of the angles, let alone two of them, right? You have to have two of them to get the angle sum formula to work out. So, with side, 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 the only possibility left is to use the law of cosines, right? So, use law of cosines to find any, I don't want to say any, to find the largest angle. Okay, largest angle is important there. Because the law of cosines is a little bit nicer than the law of sines, because when you use the inverse cosine to find the angle, the cosine will actually give you, or the inverse cosine will actually give you either a first or second quadrant angle. You don't have to choose one. And that's because the range of the inverse cosine is anywhere from 0 to pi, right? So you can get an output directly from your calculator in either the first or second quadrant. So it will tell you whether it's acute or obtuse, all right? So use the largest angle first. From there, once you know the largest angle, then you'll have an angle and its opposite side, right? You have all the sides given anyway. And so then you can use the law of sines, and you can use it to find either of the other two angles. So use the law of sines to find one of the angles that's left, and it doesn't matter which one at this point. And then you can use the angle sum formula to find the last angle, because you'll have two at that point. So the last two steps would be to use law of sines to find another angle. And again, it doesn't matter which angle, as long as it's, using the law of sines, because once you find the largest angle, you'll know the next largest angle. The last two angles actually are forced to be acute angles. They have to be first quadrant angles. And then finally, you're going to then use the angle sum formula to find third angle. Okay, so then you're done with that one. Okay. Now there is one other scenario, one other possible combination of three given pieces of information we haven't really talked about. And that is the situation where you have three angles but no sides. Okay. The problem with that, so let me write that up here. So number 4 is three angles and no sides given. The problem with having three angles but no sides is that there isn't a particular triangle that you'd be trying to find. You know that would be our A scenario, right? Three angles. But you know that any two triangles, so let me draw this a little bigger. Any two triangles with the same three angles are similar triangles, not congruent, right? So you could have all the angles here, corresponding angles congruent, but not have the same triangle. And so there's no guarantee that you'll know the length of any of the sides. Okay, you could have an infinite number of different triangles in here that all have the same three angles, but vastly different sides. Okay, so we can't actually solve a triangle that has three angles given. It's impossible. Okay, so cannot be solved. Okay, you have to basically have at least one side given, right? So here, I guess in the first situation, I have erased it now. In the first situation, you had one side given. In the second, you had two sides given. And in the third, you have three sides given. Okay? If you have no sides given, there's nothing you can do. All right? So that pretty much covers all the different scenarios. You do have to have three pieces of information to find the other three. You can't solve a triangle with just two. And 4 is more than you need. So 3 is really the minimum, and these are the different scenarios in which 3 will be, in which you'll be able to use 3 of them, or be given 3 of them.